Hello, welcome to our second session for today, where we will discuss about when performance should be planned. Before we start, I will remind you that this session will be recorded, and after the meeting or in the following days, you will receive a link with the presentation, with the session. Also, you will be able to find it on Yonder's YouTube channels the following days. If you have any questions, please use the Q&A section for asking them. And at the end of the webinar, I will answer all of your questions. Okay. So, my name is Catalin. I'm a tech lead at Yonder. I've joined Yonder more than 4 years ago, and since then I've been involved in multiple projects and verticals. I'm into adventures. I like to explore a lot, sometimes getting adrenaline from extreme sports. Also, I like to challenge myself, both personally and professionally. And for the professional part, I like to challenge other people and systems to become their best versions. So before we start, I have a question for you. What is good performance? How do you define it? For this, please answer the poll question, and we will get the response a bit later. Meanwhile, I would like to tell you 2 interesting stories related to performance issues. So, the first story is about the people transportation company, who has both software and hardware components. The framework for the main functionality used is Alfresco, which is a framework based on the Java language. Alfresco is mainly designed as a document management system. Some of the main flows for this application were related to creating or updating entities, and after that, notifying the users about the changes. These actions took about 30 to 70 seconds per entity, which is quite a lot, considering that our clients promised a response time of maximum 5 seconds. As you can imagine, the end users were very dissatisfied about it because they had to wait a lot to continue their workflow. So, what we did, we got the code and deployed the application locally. We started to analyze the code, the logs, the requirements, the database, database connections, etc., in order to identify possible bottlenecks. Unfortunately, we could not reproduce the issue on local environment. The application behaved normally. We went to their testing environment because we thought that we might have more luck there. The situation was the same. So basically, we went back to phase 1, where we analyzed the code. After a few days, we managed to reduce the saving time below 6 seconds for all the flows, some of them having a response time smaller than 2 seconds. Pretty cool, right? Of course, as you can imagine, the customers were happy about it, and also the end users, because they could do their job faster. But the question is, could this situation have been avoided? Of course, it could have, by doing performance testing with closed production environment and user load. They did some performance testing, but it was on their testing environment, where there were a few users configured. And basically, that's why they could not identify the problems during the performance testing. Doing some proper load testing would have helped them a lot, because the main flow had actions which could have been easily done asynchronously. But about performance testing and benchmarking, we discussed last time, and you can find the recording on Yonder's YouTube channel. The second story is about a module in a healthcare application built on a microservices infrastructure, basically a monolith with microservices around. For the main flow, we integrated with the case management system, which was working fine on the local and test environment. After we finished the development for the MVP, we tested locally and released it to production for a small number of users, testing group users. They got excited and they started to use the module more than we anticipated. And as you can imagine, this led to some problems. In our situation, some freezing screens. Obviously, this caused some dissatisfaction for the end users, which got reserved about using our module. So what we did next? We started to analyze each flow from both technical and functional perspective. We did some performance testing, load testing, spike testing, and also profiling on each microservice to try to determine possible causes for our issues. We managed to identify the problem, and after a small refactoring, we were good to go. Furthermore, we did some stress testing to see where the app would crash. And it turned out that we support almost 2 times the expected user load. Of course, at the end user were very happy about this. But again, the question is, could this situation have been avoided? Of course, by reading the documentation of the case management system carefully until the end. Since we were focused on delivering the happy flow for the MVP, we missed the small writing from the bottom of the page, obviously. And as you can see, anything or almost anything can produce performance issues. From my perspective, to say that an application is perfect, it's an utopia. There are a lot of factors which may cause performance issues, especially nowadays when we don't handle the memory management ourselves. So, what is the first thing one does to handle performance issues? Scaling. Scaling is the first option when it comes to performance issues. Why? Because scaling is easier and faster. It's just one click away and simple to do. But this in comparison with investigating the root causes, properly understanding the frameworks and implementation of your product, and refactoring the code to be better. Scaling is not necessarily cheaper, but it's faster and helps you solve the problem in less time. There are 2 types of scaling. You have the vertical and the horizontal scaling. The vertical scaling means adding more compute power to your existing system. For example, you can add more memory, you can add more CPU or other resources to the same machine. And this basically means upgrading your system, like when you buy a new phone or a new laptop with better specifications. Horizontal scaling means adding more nodes or instances of your application. Basically, it means replicating your application on multiple machines. But does this solution always fit? Is this the magic solution? In the first story, the improvement came after the framework was understood better. How does it work? What does it offer? What are the features and also the limitations of the framework? And also better understanding of the existing implementation, since it was done by someone else and there was a lack of documentation for it. In this situation, scaling wouldn't have worked out because we had to adapt the order of the operations that were executed, some of them to be executed asynchronously. On the other side, on the second story, it turned out that we missed a special request after the flow was entered for our case management system. And the special request would have cleared the memory for us. Maybe doing a combination of vertical and horizontal scaling would have hidden the problems. But the question is, at what cost? And there is a difference between hiding and solving the problem. So, going back again, does scaling always fit? I think you know these guys, right? Unfortunately, there is no magic formula for fixing performance issues. You need to roll up your sleeves and get your hand dirty. There are a lot of factors which impact performance, and next we will discuss about the most common ones. First, that comes to my mind is architecture. Basically, not choosing a good design for the job might become a nightmare. And that's why it's recommended to do your research before choosing the architecture for your system. Obvious when you start to design it. It is not easy to change the architecture of an application after you release it to production, but for sure it is very expensive. Also, over-engineering the architecture for a system is not recommended. Knowledge of a framework or a technology. Basically, even though we choose the best or the right tool for the job, not knowing how to use it properly can lead to some issues. Most of the time, edge case issues. And those sometimes require more time to fix the actual them than the actual implementation. Having at least one experienced person in the team should be a priority for each product manager. Good developers can anticipate issues, and this can save you a lot of memory and trouble for your application. It's almost impossible to deliver a performant product only with juniors in your team. So, for example, there is the famous problem n+1 query, which is a very common one. It is very simple, and basically this issue costed companies a lot of money. In almost all projects, you can find this issue. You have to look a bit careful for them, and you will find it. Performance testing with close to production environment and also user load. This helps you reducing the number of bad surprises after the application is released. Functional design is also a challenge for performance. Many applications have overcomplicated flows in which a lot of unnecessary data is processed or fetched. From my perspective, this is not recommended. Keep it simple. Of course, human error. It happens to the best of us on any levels, or at least where people are involved in the jobs. And last but not least, time to market. It is important for many products nowadays, and it is usually the trade-off for performance. Looking at these performance challenges, except the human error, which, can happen to the best of us, and time to market. The rest of them are technical challengers. And as we all know, for any technical problem, at least one technical solution already exists. So, what about the non-technical challenge, time to market? This battle, performance versus time to market, it's a constant battle between the developers and salespeople. Why? Simple. Because performance is important for developers and less known for salespeople. On the other hand, time to market is important for salespeople and less known for developers. And of course, the software product is somewhere between the performance and time to market. But the question is it in a perfect balance? Is it right at the middle? For example, like 30 years ago, the quality or the performance weighted a bit more. Why? Because development was more difficult, it was less popular, and you couldn't find too many applications or products doing the same thing. Selling was usually regional, and internet was not used as today for selling the same product across the globe. Nowadays, the development is much easier comparing to 30 years ago because you have access to all the documentation and you don't have to write the same functionality for every sorting or common functions. You have all the libraries and frameworks developed in these years. So basically, you don't have to reinvent the wheel every time you need something. Also, there are a lot of products with the same or similar functionality. Basically, you just need to pick the one that suits you better. On the other side, the selling strategies and models changed, evolved. There are a lot of companies which have strategy based on online selling in the other parts of the country or other parts of the globe. And basically, this is why time to market weighs a bit more than performance these days. Also, this is a reason why sometimes performance is sacrificed on behalf of time to market. There are a lot of areas where it's more important to be a pioneer than rather than to be very efficient. So, when should we have performance in our mind? After going live. It's not the best moment, yeah, because you might lose customers or even the product if the performance is not acceptable. But if you haven't done performance checks until then, it's a good point to start. Before going to production, it's a good moment, yeah, the most common one. Usually there are a few days or weeks settled for this to do the final touches of your application. Before each commit, basically this is what the customer gets, the moment of truth. Because if the code which is written for your application is not efficient, the product won't be, logically. When you have to choose a framework or a programming language, this is a very good moment because you might find out that some frameworks or some programming languages might fit better than others. And this, yeah, will make the development faster, or the testing part, or I don't know, different aspects. And that's the reason why there are a lot of frameworks and programming languages nowadays. When you design the architecture, well, basically this is the best technical moment that you can have performance in mind, because it will save you a lot of money, a lot of time, and of course a lot of effort for the implementation. When the requirements are created and the budget is settled for the project. This is a non-technical stage. This is a business perspective. This is a business stage. And many decisions taken at this time have a big impact on the architecture and on the design of the application. Let's see an example. We have two applications with different requirements. From my perspective, it's a big difference between the requirements of these two applications. Kind of like these two pictures. Both cards will get you there, but probably not on the same day or the same month. It is very useful to know from the start if you should allow some space for the engine when you start to build your platform. But my question is it all about performance? What do you think? Of course not. Performance is not everything. Especially today, when most of the developers team work in agile methodology, which of course has an impact on a product's life cycle. In agile, you usually release an MVP first, which is validated by the end users and the market. The MVP is not meant to have the best performance. Its meaning is to validate the happy flows and the functionality. If the application succeeds, development for new or existing functionality is continued. If not, it is retired in a forgotten folder. Sometimes it's difficult for technical people to understand this because, you're a technical professional and you want to deliver the best quality and the best version of your work. Unfortunately, this is not usually needed in an MVP. And the trick is to know where to draw the line between a fast or a performant MVP. Some food for thought. Performance should be planned or considered in all the life cycles of a product, from setting the budgets, defining the requirements, designing the architecture, development phase, testing phase, releasing phase. Most of the time, performance is taken for granted, but it is usually not mentioned anywhere. Because performance is taken into consideration when the performance issues arrive, not earlier. Because, we are optimistic. Everything is green in our life. From my perspective, thinking performance should be a mindset. And I think that all good developers have it, no matter what language and or framework they use. As a developer, you should know by default that you have to write efficient code. Performance is like trust. You have to put some effort to gain it. And the effort consists in designing the architecture and the infrastructure and so on, implementing, testing, profiling, you name it. There are a lot of places where you have to put some effort. And last but not least, performance of a product is not given only by the technical skills. Nowadays, it's influenced by external factors like, recruitment and time to market and some other factors. But getting back to the first question, how do you define performance? And I see that from your answers that the most common response is the end user is happy with the product. And I agree with you. From my perspective, good performance is when the customers use your product, because that is important to a product to be used. They are satisfied about it, So the end user is happy, and also they pay for it because, yeah, as a business, you have to earn some money, to earn money somehow. Thank you. Now that if you have some questions, please. I see a question here from Gabriela. If you can do one kind of performance test, what would that be and why? Well, there are 5 or 6 performance tests, 5 or 6 types of performance testing. I think I would choose load testing because load testing helps you. Load testing tells you if your performance is, if your application will meet the requirements for expected user loads. So basically, if you expect to have like 1,000 users per second, and you do a load test, and if your application, if that test won't fail, yeah, of course, you can go to production with that and be sure that you won't have complaints from your customers. That's a good question, Gabriela. Thank you. Another question from Richard. How would you gather customer performance expectations? Are they always written as requirements? Well, first of them, you need to ask them, what are their expectations? Because, yeah, everyone has a perspective of the reality or some expectations related to anything, from a phone, from a car, from an application or so. But if you don't ask, okay, can you meet these requirements? Can you be this fast? Or at least how fast can you be? What can you provide me for this amount or this money? Because, yeah, this is important to know. For example, if we buy a car, you know that it will reach 100 kilometers per hour in 5 seconds or 8 seconds, whatever. But maybe you're not interested into that. But yeah, some of us are interested into that. So basically, we need to ask them. And the second part, if they are always written as requirements, no, they're usually not. And that is the real problem, because no one asks about it. But in the end, everyone has expectations about it. Hope that gives you an answer, a complete one. Thanks, Richard. Another question, sorry, from Tony. Do you use or recommend analytics or anonymized logs from production environment from the performance perspective debugging? Yes, I do use, and also I recommend. Why? Because it's very important to know how the system behaves, and not which user accessed or which user had this problem. And yeah, usually performance issues arise when there is a load of users in the application. And yeah, it doesn't matter from my point of view as a developer if user A or B or Z had the issue. It matters that a user had an issue. So yeah, I do recommend analytics and anonymized logs, and also logging is very, very important for performance investigations. It will save you a lot of trouble and time if you have good logging in your application. Thanks for the question, a very good one. I have another question here. Who should do performance testing, developer or tester? That's a good one. From my perspective, both of them. And the reason is simple. First, the developer should do the performance testing because he needs to meet the acceptance criteria of the story or of the request. Then the tester should do performance testing because it needs to check that if the acceptance criteria is met. So basically, both of them should do performance testing. Yeah, thanks for the question. Any other questions related to this topic? I see another question from Liana. How can architecture have impact on performance? Yeah, that's a very interesting one. Basically, when you start to design your application, you start to design the architecture, the language, programming language that you will use, the frameworks, the modeling of your application. First, there are different programming languages better than others for certain tasks. And that's a good reason why there are a lot of programming languages nowadays. Also, yeah, I can give you some examples. If you have if you want to use a NoSQL database, but in your business you have a lot of connections and relations between your entities, it might not be that good to use a NoSQL database, and you might want to use a relational database. Or, for example, if you have if you want to use a microservices architecture, but your business is very, very simple, and you could make it faster and simpler by having only one component. Yeah, there's no reason to over-engineering the solution. Another situation, dividing the domains of your application in separate microservices and having a strong connection between the domains. This will make you walk through a lot of microservices for only one query. And for each request and response, you have the time for marshalling and unmarshalling the request and the response. And of course, this increases the time of your response. Thank you for your question, Liliana. I see another question from Richard. Are there any of the shelf tools you use to assist with performance testing? Well, basically, it depends on the situation, but until now, I've tried to use as much as possible tools which are free, but also use some paid ones. Yeah, I used Gatling, for example, for triggering performance tests. I used JProfiler for profiling part. Yeah, Splunk for analyzing the logs and getting some analytics from them. Also JMeter. There are a lot of tools, but the thing is that you have to know what you want to test. The same as, for example, integration testing. You need to know what you want to test, and then you choose the best tool for it. I hope this answers your question. And I see a question from Razvan. Any tooling you recommend for doing load, endurance, spike testing? Well, there are a lot of tools nowadays. Like I mentioned, I use Gatling for this. Also, JMeter is okay to use. If you want, you can do also from Postman some requests. You can do also from which was that? I think Selenium. Also the UI automation. It depends on how you configure the tests. But yeah, there are a lot of tools to do that. And each tool should, or each good tool should provide you with a good report for this. Okay. So, any other questions? Yeah, if not, please, you can contact me on my email address, and we can we can discuss about them also later offline. Yeah. As a reminder, this session is recorded, and you will find it on Yonder's YouTube channel. And since there are no other questions, thank you for your presence, and see you at the next webinars. Have a great evening.